Okay, we're now asked to sketch a graph, so I'll draw myself some axes, I suppose, of y is equal to the square root of the square bracket of x, where the square bracket of x is what we do if we take a number x and we look at the whole number that's less than it, well, that's immediately less than it, so if we chop off the fractional part. Okay, so let's think about what happens when x is 0, the whole number that's at most as big as x is 0, so y is 0. And that carries on being the square bracket of x until x is at least 1. So y just stays at 0 until x is 1. So let's put 1 there. And when x is 1, then the square bracket of x suddenly takes a jump and it becomes equal to 1, and the square root of 1 is 1. So we start taking that value there. But then, because what we're doing is we're waiting until we take another jump, so we're waiting until the next number, which is at most x, goes up, well, what are we doing? We're saying y is going to stay as 1, at least until x is 2. And then when x is equal to 2, all of a sudden the square bracket of x becomes 2, and then y is equal to the square root of the square bracket of it, so let's put a root 2 here, and we're going to take a jump up, I should do that in yellow, to root 2. And now, again, we're going to stay the same because the square bracket of x isn't going to change until there's another whole number that's bigger than 2, which is at least x, and that's going to happen at 3. So we're going to have another kind of start function. And we can see that we're going to keep stepping up. And what's this going to step up to here? Well, it's going to be the square root of 3. And now we can just see what's going on. We can kind of guess that we're going to go to 4, and we're going to go across, and we're going to go up at 4 to the square root of 4, which is better known as 2, and to 5. We'll keep going, and then we'll go up to the square root of 5. And notice also that these steps are going to get closer and closer together as we go along. So that's going to be our sketch of y is equal to the square root of the square bracket of x. Now we'd like to use this to show that the integral between 0 and a of our function that we've got here, which is the square root of the square bracket of x with respect to x, is equal to the sum from r equals 0 to r minus 1, sorry, to a minus 1 of the square root of r. Okay, well, the only way that I can think of to use a sketch to think about an integral is to relate it to the area that's underneath the curve, which we know is an interpretation of an integral. So what's this going to be? If I pick a point A when A is an integer, which I think I'm allowed to restrict to in this case, for example, when A is 5, what do I do? Well, I come down to here, and I'm looking at this area here. Okay, this is broken up nicely into a bunch of rectangles, all of which have width 1. And it's easy to calculate the area of rectangles. I just take the width and I multiply by the height. What's the height of each rectangle? Well, because y is the square root of the square bracket of x, it's going to be root 1 there, it's going to be root 2 here, it's going to be root 3 here, and it's going to be root 4 here. Now, I just need to check that when I add these up, I'm going to, at most, the thing minus 1, and that's OK, because if I drop down to, instead of having this as 5 now, let's think about general A, then the last rectangle that I count is going to be the rectangle which has A at this corner here, and that's going to be of height root A minus 1, because we haven't yet plugged A in. So by looking at this area, I can just write down in terms of the rectangles that that's what I'm going to get. Okay. So now we're asked to show that an integral between 0 and a of a different function, 2 to the square bracket of x, has this formula. And it might be quite tricky to know where to start, but the last time what we did was we sketched the function first, and then we thought about how we could think about the integral in terms of the area. And I want to do a similar thing here, because I can't think of another way to actually integrate this, because I don't know anything about integrating functions involving square brackets. I don't know any formulae to do with those at all. So we want to think about areas again, so I'm going to do another sketch. So let y equal to floor of x. Now what does this look like? So again, when x is 0, I'm going to do a similar sort of stepping argument, because I'm only ever going to change my value when x gets a whole integer larger. So when x is 0, y is going to kind of line at 1 until x is 1, and then it's going to line at up to 2. And then I suppose then it's going to be 2 squared, which is 4. And then it's going to go up to 8, and so on and so on. Okay. So what's this going to be? Well, again, I'm broken up into rectangles of width 1. So the height of the nth rectangle will actually be given by the value that y takes in at the bottom left corner, which is going to be 2, well, it won't be 2 to the n, because that would be what it would jump to over here, so it's going to be 2 to the n minus 1. So what my integral is going to do is it's going to be, thinking about it in terms of these areas again, if I go up to some a, I know that my last term is going to be, by the logic we just used here, it's going to be a minus 1 to, let's sum over r. And what's my first term going to be? Well, my first rectangle has height 2 to the 0, so it's going to be 0. Okay, so now we've gone from an integral to a sum, and we actually know things about adding up sums. I know that I don't actually need square brackets here. I can just use r itself, because the square bracket of an integer is just the integer itself. Okay, so this is a geometric series, and we know how to add those up. We take our first term, well, that's 2 to the 0, which is just 1. And then we're going to multiply by 2 times, well, we've got a terms going from 0 to a plus 1, and we need to subtract off 1. And then we want to divide by our common difference, minus 1, and our common difference is 2. And that's going to give us 1 over 1, so that just cancels, which is 2 to the a minus 1, which is what we wanted to show. Okay, now we're asked for a similar looking integral. It in fact is an identical integral, but we've no longer got the restriction on a that it's an integer. So we're going to have to think a little bit more. The first thing that occurs to me when I do this is that, well, I can break it up. I kind of have the bit of a that's kind of worrying me is its fractional part. It's that a is not a whole number. I can deal with the part of it that is a whole number, but then I'm going to have to think a little bit more about what happens between, I suppose, the square bracket of a, this notation that we've been using, and a itself. So there's going to be an interval here where I don't know what is happening. I know that I can split integrals up in this way, so I can take this to be from 0 to the square bracket of a, 2 to the x dx, plus the integral from the square bracket of a up to a of 2 to the square bracket of x with respect to x. Now, this is something I know how to evaluate. Because the square bracket of a is an integer, I can apply what I did in the previous part of the question, and I know that this is 2 to the power of the square bracket of a minus 1. And now I need to think about integrating this function. So what does it look like? We found sketching things to be generally helpful, so let's do it here. I've got the square bracket of a hanging around somewhere, and I've got a somewhere else, and this distance is less than 1, so let's draw a 1 here. So at the square bracket of a, 2 to the square bracket of a is going to just look like that. And because this distance is less than 1, actually it's not going to change value the whole way. So I'm going to get a rectangle, but now it's not got width 1. It's got width, well, I suppose it would be a minus the square bracket of a. So this, again, is a rectangle. It's of this width and it's of this height. So I know, actually, that this integral is equal to a minus the square bracket of a times 2 the square bracket of a. And as a very quick sanity check, but let's just check that this does agree with what we got before when a is an integer. Well, when a is an integer, a minus the square bracket of a is 0, so we lose this term and we recover this one, which is reassuring because that's what we got in the last case.